going on, everybody? So, today we are going into lesson 20. And lesson 20 is in semester 2, unit 3. So, it's not in the same section that we were doing it in iTunes. I'm kind of jumping around with this whole Corona thing going on. This was actually supposed to be the lesson that was after limits. So you guys may recall a whole like 7-8 weeks ago we did limits. The next lesson was supposed to go into something called derivatives, and this is like towards the end of pre-calculus, early calculus. Hannah, I am sorry to hear, but at least you will get them tomorrow. That'll be good. So you will see the word limit today, but we're not going to do anything crazy with limits that we've done in the past. There's just one little thing that I have to show you with the limit, but I'll show you guys once we get towards the end of the problem. I'm going to teach you the definition of a derivative. A lot of you guys are not going to really understand it, and it's okay. This year, we're not going to go into graphs of derivatives, and we're not going to do word problems with derivatives. I'm just going to show you how to solve them algebraically, just in case if you do see it early in your college careers. Okay, so the definition states the derivative is an equation that yields the slope, or what we call the tangent, at any point along a curve. If the function is represented by f of x, the derivative would be denoted as f, and it has that little tick there that's called prime x. So this, if you guys ever hear me say it, is going to be known as f prime. That's not how you spell prime. X. So if you ever hear me say f prime x, that just means it's that little apostrophe that's up there. Okay? So this definition says that if I pick some point that is on this curve, let's say I pick a point over here, that means if we were to find the derivative of this, it's only going to touch that point once, and it's going to be represented by a tangent line. And tangent lines are really, really hard to draw, but what it's going to be is a line that just barely touches that function. And this will work every single time, and it's always going to be on the outside, because if I drew it the other way, if I drew the line this way, it's actually going to touch twice, because this line is going up forever and ever and ever, so it's going to cross. So it can only be on the outside when we draw it. So if I were to ask you guys to find the derivative of this point, the definition states that the solution is the line that is tangent to that point, and it falls on the outside of the function. So again, a lot of you guys are not going to really understand that unless we start going into word problems and going into graphs. Derivatives are important for, like, if you're going into maybe like a science field. I know the one big thing is if you guys ever get a traffic ticket, when they are using the speedometer to see how fast you're driving, the calculations that work in the speedometer can determine your exact speed and acceleration at a certain point in time, which is now me talking physics stuff. So that's where derivatives come into an importance. So not only is this a topic that you'd see in pre-calc or calculus, it is a topic that you could see in physics if you have to take that in college. Now they call it calc-based physics. So if you have to take physics in college, make sure you pay attention to what type of physics it is, because if it is calc-based physics, I highly, highly recommend that you take calculus first. Okay? If it's just regular physics, like what we offer here at Silver Creek, then you guys will be fine. But if it's calc-based, you have to take calculus first. At least that's my recommendation. So enough of all that. let me come down to this formula. I'm only going to do these two questions for you guys, A and B. And then next week on Monday, we'll start going into a different way of solving a derivative. So I have to show it to you guys with limits first, and then there's a shortcut way of doing it. The reason I have to show it with limits is sometimes you may have to solve a problem that is all variables with no numbers, and this is the only possible way of doing it. So they call this the limit definition of a derivative. You don't need to know all that stuff. I'm just going to show you the algebra behind it, show you guys how you can solve it, and then you guys will feel pretty good. So first of all, I gave you the function f of x, and I gave you two of them. We'll focus on the one that's over here on the left. So we have f of x. This function, the limit definition, has two things in it. It has the f of x over here, which we already know. That's this part right here. But it also tells us that we need to solve for the f of x plus h. And the h represents what we would call the position of the function. It's just that whatever that point may fall on inside the graph. So h we don't technically know right now. So what I'm going to do is, since we already know f of x, we have to figure out what f of x plus h is going to be as well. So in order to find f of x plus h, what that really means is all we're going to do is take the x plus h and plug it in for the x for the f of x. So this is really starting to go into pre-calculus and calculus. But what I need you guys to understand is it's still substitution. It's still stuff that we have done in the past. So I'm just going to take that x plus h and I'm going to substitute it in for x. And then what I'm going to do is I'm just going to simplify that down to the best of my ability. So x plus h squared really just means x plus h times x plus h plus 5. I'm going to double distribute the x plus h and the x plus h. And if I do that, I'm going to have 3 times, and I'm just going to do the math off the top of my head. That's going to be x squared plus 2xh plus h squared plus 5. And I hope I'm not like losing anybody right now that's going through this. But then I'm going to just distribute that 3 into the parentheses, and I'm going to have 3x squared plus 6xh plus 3h squared plus 5. Okay? So now what I'm going to do is, now that we know f of x, we also know f of x plus h. We're just going to take that information and plug it into the formula that I wrote above. Oops, I'm going to choose pink. So in order to find the derivative, I'm going to plug it into this formula. So it says f prime of x is equal to the limit as h approaches 0. And you guys may have forgot what that whole limit thing means, but I'll get to that in a second. And it says the first part that we have to plug in on the top of the fraction is f of x plus h. Well, that's what we just solved in red. So the first part I'm going to do is substitute in 3x squared plus 6xh plus 3h squared plus 5. So all I did was I took this part right here and I substituted it in for the part that says f of x plus h. I'm just plugging it in. We already solved it. We already know what that answer is. Then I have to subtract f of x. So now I'm just going to write minus, and we already know what f of x is because that's what was given. That was that 3x squared plus 5. So we don't have to solve for f of x. We just have to plug it in. And I just have to make sure anytime I substitute, I include parentheses. And that is all over h. So now I just have to simplify it. So I have equals the limit of h approaches 0. We can't simplify anything in the first parenthesis. So the 3x squared plus 6xh plus 3h squared. This is a lot to write down, I'm sorry. Plus 5. But then it says we are subtracting 3x squared plus 5, so we have to distribute that negative in. So it would be negative 3x squared minus 5. All over h. So this looks really confusing, but all I'm doing is just doing the substitution, and now I'm solving it with the algebra. So now I got to combine like terms. So I can combine the 3x squareds, which you guys should notice one's positive, one's negative, so they're technically going to cancel out. I can also combine those 5s. I have a positive 5 and a negative 5, but those can cancel out. So now I'm really just going to be left with 6xh plus 3h squared all over h. And I still have that limit of h approaches 0 out front. So this is going all the way back to limits now. So we did everything we can do to simplify it down. Right now, that's the answer. And that's not a nice answer because I'm asking you guys to find the tangent. So we're trying to use the formula to find the derivative so we can find the line that reaches that one point like I was showing in the graph above. Well, we can't just plug 0 in. So notice this says h approaches 0. But if we just plug 0 into that fraction, so if I plug 0 into this fraction right now, you guys don't have to write this down because I'm going to erase this. We can't solve that. Because remember, when we have fractions, we cannot put 0 in the bottom of the fraction. If you put 0 in the bottom, that's going to be undefined. So before you guys can actually solve a limit, I taught you guys, this is going back 7-8 weeks now. This is what we did before this whole coronavirus thing started. What you have to do first is factor. So if you guys look at the top, there's an h that goes with the 6x, and there's an h that goes with the 3. So technically, you could pull an h out and be left with 6x plus 3h. And actually, you know what? I can actually, if I'm doing GCF, I could pull out a 3h. So really, inside the parentheses, I'm going to be left with a 2x plus h if I'm going to do proper GCF. And now you guys should notice you have an h on the top and bottom that can just cancel out. So we're just left with 3 times 2x plus h. Now, because we factored, we can take this 0 and plug it in for h, and now we can solve it out. So we'll have 3 times 2x plus 0. Well, if we distribute the 3, it looks like our answer is just going to be 6x. So we did a lot of work here. And rightfully so. If we're going into calculus, you guys are going to get more of an understanding of all the processes that you have to go through to find a final solution. So everything we did right there, it's taking a lot of stuff that we've already done before and trying to put it all together. Okay? So I'm teaching you guys the long way of it right now. A lot of you guys are going to be upset with me because you're always like, Sadler, why do you teach us the long way and then you teach us the shortcut? And the reason why is because in the future, you may see a problem where there's no numbers. And I may or may not give that to you guys next week. I haven't decided yet. I'm just showing it to you guys with numbers because it's easier to explain that way. But eventually we may see something that said ax squared plus b. And then we have to try to plug it in and solve. And it gets a little bit more confusing when it's all letters. Okay, so I'm going to do the same thing for b. I'm going to do all the same steps. I'll call it quits for today after that. but I'm just kind of showing you the gist of this. What we're trying to do is we're trying to find the equation of the line. So the equation of this line would be y equals 6x. Okay, so that would be the slope. The slope was 6 over 1. As far as the next one goes, so let me go back up so we can see that original function. This is f of x. So I am already giving you the f of x up here. I already gave that to you. What we need to do is we have to find f of x plus h. So that's what I'm going to solve next. And this one gets a little bit ugly because it's a trinomial. So we have to do a little bit more multiplying this time. So I'm going to have 2 of x plus h squared minus 16 times x plus h plus 35. And I'm going to save a little bit of time for you guys because we already did x plus h squared. We did that over here. X plus h times x plus h. We already said what the answer was. So I'm going to skip over the second line. And I'm just going to say that this is going to be 2 times x squared plus 2xh plus h squared. And then I can distribute the next part, which was negative 16x minus 16h plus 35. So now I'm going to simplify that down, and then I'm going to combine like terms. So I have 2x squared plus 4xh plus 2h squared. And then there's nothing else we can combine over here because we don't have any like terms. And now I'm checking, do I have any like terms here? It's not looking like it. Yeah, I don't have anything I can combine. So we now have our f of x plus h is this long thing down here. And it looks complicated because it was originally a trinomial. But what we're hoping for is if we take that red and we take that blue that I have highlighted and plug it into the equation, we're hoping a bunch of stuff is going to cancel out. So because we have the scissor tool on our iPads, I'm going to make life a little bit easier so we don't have to write all this down. I'm going to copy this whole thing. And now I'm going to solve the formula. So the formula is f prime x is equal to the limit as h approaches 0. We have this big fraction. The part that I just copied is what's going to come first. So I got to shrink this down so I could fit it on there. So that was the first part. And then I have to subtract the second part, and I'm running out of room, so I'm going to even have to shrink this whole thing down. So I'm going to subtract the f of x, which we said is 2x squared minus 16x plus 35. And that's all over h. That is what the formula states up top. So this is the limit definition of a derivative. So as you guys can see, when we did a trinomial, this creates a lot more work for us. There's a lot more numbers we have to write down. So if I went into 4 terms or 5 terms, it can get pretty crazy. And that's why I plan on next week showing you guys kind of a shortcut method. I guess it would be considered a shortcut method for a derivative. So from here, I have to simplify it down. Well, the only thing that I can simplify down, so I'm going to copy everything again and just paste it so I don't have to rewrite it all. The only thing we can simplify down is what's in blue on top. Not all of it, just right here. Because we have to distribute that negative. So if we distribute the negative, we're going to have negative 2x squared plus 16x. Oops. Why does the text pad keep coming up? Minus 35. Because we're distributing that negative in. And technically, these parentheses... Why is my eraser so big? Those parentheses will disappear because there's nothing we can combine in there. So now I'm just looking through to see if there's anything that can cancel out. And if we were to do that, we'll notice that the 2x squareds will cancel out. We'll notice that the 16x's will cancel out. And we'll also know that those 35s will cancel out because they're all opposites of each other. So really, this formula is going to be broken into 4xh plus 2h squared minus 16h all over h. And again, we are still trying to do the limit as h approaches 0. Just like before, we can't take that 0 and plug it in because if you do, then you're going to have a fraction that is undefined. So before you plug in the 0, the last thing we have to do is factor it. So the only way we can factor this is if you look at the top of the fraction, you'll notice that you have a 2 and an h in common. So I'm going to pull both of those out to the front. And on the inside, I'm going to be left with a 2x plus h minus 8. And on the bottom, we still have an h. But now you'll notice that the h on the bottom will cancel out with the h on the outside. So really, we just have 2 times 2x plus h minus 8. Now we can take that 0 and plug it in for the h, and we can figure out what the equation of this line is going to be. So if I plug it in, I'm going to have 2 times 2x. Well, if h is just going to be 0, I could put minus 8 because that 0 is just going to disappear. And if I distribute the 2, the equation of the line is going to be 4x minus 16. So what we did is we found the tangent, that went through the point that we began with. Okay? So a lot of you guys are going to be, maybe you guys felt okay with the algebra, you felt okay with the math, but you're to the point where you're like, why the heck am I doing this? This doesn't make any sense to me. And that's okay. Rightfully so. That's where you guys should be right now. Right now, I just wanted to practice through the algebra. I'll talk a little bit more about derivatives and the shortcut next week, and then I'll talk about the importance of derivatives. So the importance of derivatives allows, like I was saying at the beginning, the biggest thing is probably working with a speedometer. It can actually determine how fast you are moving with that infrared laser that's hitting your car. It's all being done kind of using this formula at a fast pace. Again, I know that really doesn't make a lot of sense, and we have the technology that can do it, but this is just showing you guys the proof behind it, which is a lot of math. A lot of math is really just proof. Okay? So as far as homework goes, don't worry about homework number 20 right now. Homework number 20, I would rather prefer that you guys use the shortcut, and I think you guys are going to want to use the shortcut as well after seeing everything we just done today. So we'll do that on Monday, and then we'll do some more practice with derivatives on Tuesday, and then I'm going to go into some other derivative rules throughout the next couple weeks. Okay, so that's all I got. I hope you guys enjoy your weekend. It is Mother's Day on Sunday. Make sure you guys all do something nice for your mother. Happy Mother's Day to any mothers that could possibly be watching in the background. It is also my birthday, so be sure to send me an email or something. I like getting birthday wishes, so email, remind message, whatever. Just contact me and say hello. Even if it's not my birthday, please contact me. Half of you guys don't. Other than that, yeah, that's all I got. So I will catch you guys later. Everybody have a good one. Enjoy your weekend. Stop by Zoom tomorrow if you need to. Turn in any homeworks that you guys are missing. I'll see you guys later.